All righty. Let's go ahead and get started. Good morning, everyone. Welcome to the NAIR Pilot and CU RMAC webinar series. We're excited to have everyone here for our next CU RMAC webinar. Upcoming, we have a 75-minute presentation with about 10 to 15 minutes at the end for a Q&A. So in Zoom, we have the Q&A function available, so please submit your questions through there, and all of our questions will be answered at the end of the presentation. Um, this session is going to be recorded, so if you'd like to go back and rewatch, that video should be posted to the NAIR Pilot YouTube channel within about the next 2 weeks. Today's presentation, we have Intro to AI for All. Our presenter here is Nabeel Alzahrani. Excuse me. And Nabeel, thank you so much. If you'd like to share your screen, the stage is yours.
Thank you. Do you see my slides?
Not at the moment. You may have to share them again.
Okay, let me see.
You might
Share.
have to stop sharing, Cassian.
Yeah, it should be able to be through both, but I'll go ahead and stop my share regardless.
Okay, share. Do you see my screen?
Yes.
Nabeel, we're seeing your presenter views, so there, perfect.
Now you see my slide?
Yes.
All right. Hello, everyone, and welcome to this presentation, which introduction to AI for all. So first, before we start, let's talk about the biggest news about AI recently. So the latest and most important news about AI is the Nobel Prize for last year, 2024, for physics. Nobel Prize for physics was awarded to computer scientists for working in artificial neural networks. Also, the Nobel Prize for chemistry was awarded for computer scientists for solving the AI protein folding problem. It wasn't solved for more than 50 years. Then we talk about also in the news, a big company like Microsoft, Google, Amazon, they're planning to use their own nuclear reactor, to power their AI system because there is no enough electricity to power AI systems. And we'll talk about more details about the electricity need for these AI systems. Also, AI generate media that indistinguishable from reality. For example, the photo here on the right side for this young lady is generated by AI, and this young lady does not exist. It's completely generated by AI. And also, if you can see this video here, for this older lady, it was actually generated completely by AI, and she does not exist completely by AI. So as you can see here, the image credit for the young lady is from a website called thispersondoesnotexist.com, and the older lady video was from openai.com. So let's summarize this presentation. So this slide actually summarizes the whole presentations. First, we'll talk about artificial intelligence, then we'll go inside artificial intelligence and talk about a specific class called machine learning. Then we'll go inside machine learning and talk about a specific class called deep learning, and go inside deep learning and talk about generative AI. So this is a summary of the whole presentation. So before we start, let's define what is AI. What is artificial intelligence? So artificial intelligence is the science of creating machines that simulate human intelligence. So the phrase artificial intelligence is not actually a specific hardware or a software or a methodology or a method. It's just a phrase that covers anything that try to simulate human intelligence, whether it's a hardware, a software. So it's not really a specific thing. It's just an umbrella phrase that covers anything that try to simulate human intelligence. So let's talk about the history of AI. So AI is not new. It has been going for more than 80 years. We'll go quickly through the history. So it started in 1940. That's what we call the foundation of AI by the godfather of AI, um, Alan Turing, where they introduced the phrase artificial intelligence and also introduced the concept of artificial neural network. We'll talk about them more in next slides. Then in the 60s, they start developing a chatbot, and we saw a chatbot, LSI, which is very, very specific for a specific domain. So that's the beginning of chatbot at that time. Then in the 1980, we saw what we call AI winter. AI winter is when there is less funding was provided for AI research and AI system because the AI system and research at the time did not meet the need as they announced because these programs, this AI system was built for a specific task, for a specific domain. So it wasn't as they announced to simulate human intelligence in a generic domain. Then in the 90s, IBM Deep Blue AI system defeated the chess world champion, Gary Kasparov, and that bring AI back to the mainstream. In 2000, we saw the genesis or the beginning of generative AI by the work of Jeffrey Hinton, who is actually the Nobel Prize winner for physics for his work in artificial neural networks. Then in 2010, IBM, their system called IBM System Watson, when a TV show called Jeopardy beat human in that TV show. It's a famous TV show. And that's bring also back AI to the common dialogue. In 2020, generative AI reached a new horizon when OpenAI company introduced GPT-3 and Microsoft introduced their AI system and Google to introduce BART. So this is a summary of AI for the last 80 years. So let's talk about AI types. There is multiple AI types. So let's talk about the first one, which is in short called narrow AI. Narrow AI, we have it right now. It's almost in everyone hand and pockets, like Siri or Alexa or Cortana, whether it's in your iPhone or Google phone or Windows or Mac. So simply, narrow AI is an AI that can accomplish a specific task in a specific domain. General AI is AI system when they work on all domains and they beat human or intelligent in all domain, which is not available right now. It's expected to be available in 2040, which is also go by the term AGI. If you heard about AGI, that's a general AI. The next one is called super AI, which is expected to happen 2050, which is also goes by the name artificial superintelligent or machine learning, where machine gain consciousness and not only beat human, but also gain consciousness. And if you heard in the media or the news or publication about existential threat, they're actually talking about this type of AI, super AI or ASI. So that's when, if you heard about the existential threat from AI, they're talking about phase 3, not phase 1 or 2. So let's talk about AI technique. There is multiple technique for AI, and we'll focus in this presentation about machine learning because it's the most common technique. But for general introduction, there is machine learning, and also there is NLP, natural language processing, and we have also automation and robotics, and we have machine vision. Now, these domains interact with each other. Now, they're not completely isolated, but the reason we are dividing them because they have different algorithm, different focus. but actually sometimes they interact with each other. In this presentation, we'll focus on the technique called machine learning because it's the most common type of AI. So let's talk about machine learning. What is machine learning? So machine learning simply is the science of creating machine that learn from data. So the most important phrase here is learning from data. And let's talk about that more in next slide, how machine can learn from data. So before we go and talk more detail about machine learning and learning, let's talk about a computer program. So in this presentation, we're going to assume computer program and program or code or algorithm mean the same thing, even though algorithm mean a little bit something else, but for the sake of this presentation, we'll assume they're all mean the same thing. So if you use a calculator before, that means you already wrote program before. So as an example here, if we have this simple example, 1 plus 2 equal 3, 1 is the input of the program, 2 is the input of the program. 1 plus 1 is your program. So program is you define the relationship between input to reach an output, and number 3 is the output. So if we want to summarize in a table, your input in this simple example is 1 and 2. Your program is using symbol, like here we're using plus, to define the relationship between the input to reach an output. So we can generalize that mathematically. Input here, for example, it can be x and y, and the program can be a function in effect using x and y, and this is the relationship that we define using the function, and the output is f. F is the function, the result. Now let's see the difference between traditional programming and machine learning using this simple example, using the calculator example. So in traditional programming for the last 50 or 80 years, this is how we program computers. We give them the input, like 1 and 2 in this example, simple example, and we write a program that define the relationship between the input to get the output. So that's what's traditional programming. Now, how does that differ from machine learning? In machine learning, we provide the input, which is 1 and 2, and we provide the output. Notice the difference. We provide the input and the output, and the machine learning find the relationship between the input that produce the output. So that's called the program. In AI, we call this program, we call it a model. So I will use the word model after this slide. A model means in AI, the program that was created by the machine learning from the input and the output. Now, when we use this model with new data that we have never seen before, so the model is the F function, which is F function is that define the relationship with input, we can actually apply it with new data we have never seen before. And guess what? It's going to work. And that's the difference between machine learning and traditional programming. So simply, you can say machine learning write their own code, write their own program by just seeing or using data. So how to build a machine learning? Machine learning goes through a process of multiple steps. So the first step, you get your data, whatever your data, pictures, images, videos. So you get your data. Then you clean the data, clean them, removing redundancy, solving missing data, or manipulating data to change them to be in a standard format. Then we divide the data to two groups. Let's say divide your data to 50% and 50%. 50% we use for training and 50% use for testing, even though in reality, that percentage is not 50-50. It's different, but for the sake of this presentation, to make it simple, we'll just say 50-50. So then we use the training data to train the model. And if we don't get the expected result, we call it train error. So through training, we get training errors. And through testing, by using the testing data, we get test error. Then we improve, we go back and improve to reduce the training error and the testing error. So this is the life cycle, how to build a machine learning system. So in machine learning, there is a very common terminology. One is called underfitting. So let's try to understand what's underfitting. When you hear it or when you read it or read anything or hear anything about AI, you might hear the word underfitting. So what is an underfitting? In this example, we have stars and circles, and we try to write a model to differentiate between them. So if a lines, which is this red line, is a model, goes directly through them without paying attention to the circles and the stars, we call it an underfitting model. That means it's have high training error and high test error because literally it just ignores the data. It's not aware of the data. So that's we call it underfitting. The extreme of underfitting is overfitting, when the model literally take in consideration every single input data and try to distinguish between the two type of data. And this is called overfitting because it's very, very custom to the training data, but it doesn't do well with data that have never seen before, which is the test data. And that's why we have low training error, but we have high test error. What we're looking for, we're looking actually something in the middle, which is called optimum. We want to see something with a model with low training error and low testing error. Now, machine learning type, there is multiple machine learning type. We have the main important one in AI called supervised machine learning and unsupervised machine learning. So in supervised machine learning, as you can see here, we have the input, the pink color, X1, 2, and 3 are the input. And we provide the output, as we saw in the calculator in the previous slide, to provide the input and the output. In unsupervised machine learning, we only provide the input, we do not provide the output. And that's the main difference between supervised and unsupervised machine learning. In supervised machine learning, we have two categories. One is called regression and one is called classification. So in regression, we're trying to find a number, a mathematical value, whether integer or real. So that's regression. For classification, we're just trying to classify two type of data or more than two type of data. Binary classification usually used in healthcare system to detect if there is a disease or no in a patient, whether they have a specific disease or not. We'll talk about it more in the next slide as an example for binary classification. Also in classification, we have multi-class, not only two classes, we can multi-classes, multiple classification. So still that's considered supervised learning. In unsupervised machine learning, we don't provide the output, we just provide the input, and the machine learning system try to find any relationship between the input and cluster them in clusters. For example, if we have a group of flowers, they can cluster them by color or by shape or whatever to find the relationship between them. And again, this is completely automated with no human intervention. They try to find something common between these items and they cluster them. So let's talk about binary classification in healthcare as an example. So let's say we have two groups of people, group A and group B. Group A, let's say they have a specific disease, let's say diabetes in group A. And group B, they don't have that disease, so they don't have diabetes. So let's say here on the left side, we have our AI model, or let's say AI tool that detect diabetes. And this AI tool have two indicator, plus or minus. Plus means this person has diabetes, minus this means person does not have a diabetes. So this tool shows plus for group A, it's called true positive. That means the tool detected true positive. That person has a diabetes. And if the tool shows negative for a person who has, in group A, we call it false negative. Again, if the tool shows positive for group B, person who doesn't have a diabetes, we call it false positive. And if the tool shows negative for a group B person, we call it true negative. So we can actually calculate mathematically the accuracy of this binary classification using something called sensitivity and specificity. And this is how actually we calculate the accuracy of our AI system mathematically, given that the number of group and number of group people in group A and B are the same. We call it balanced data set. Otherwise, the sensitivity and specificity might not be accurate. So when building a machine learning, you don't need to build everything from scratch. There is actually algorithm available as software library. You can onboard them to build your machine learning. You don't need to build from scratch. So if you are building, if your problem has to do with text analytics, text analysis, there is this algorithm that you can use, machine learning. If you are doing regression, also there is available algorithm based on the problem and the goal, what you're trying to do. If you are doing recommenders is like what you see in YouTube or Netflix. If you watch YouTube and sometimes you see um, a sign, this YouTube, you might like this YouTube or recommended for you, or if Netflix, let's say this movie are recommended for you, this is actually how they do it using recommender machine learning algorithm. If you are doing clustering and supervised learning, you can also use this algorithm. If you want to do anomaly detection, you can use also this algorithm or multi-class classification or two-class or image classification. So as you can see, you don't start from scratch. There is always software library available, open source, that you can download and use to solve the problem that you're trying to solve. So let's move to deep learning. We're now covered what's artificial intelligence. We talk about machine learning. Let's talk about deep learning. So what is deep learning? Deep learning, if you see the definition, it's actually the same as machine learning because it's a category, it's a class for machine learning. As you can see the definition, it's the science of using neural network to learn pattern. But what is the difference? If you try to find the difference between machine learning definition and deep learning definition, the only difference is using neural network. So both of them are learned from data, but the only difference, deep learning use neural network. And that's what we're going to talk about in the next slide. What are neural networks? And before we talk about neural network, we need to talk about the neuron themselves. So we'll talk about the human brain and neuron and see how we can use that to build artificial neuron and artificial neural networks. So let's talk about biological neuron. Let's talk about the human neuron. So a neuron is a nerve cell in the brain, in the human brain, that from a computer science perspective, it consists of three main components. And that's what we just need to know for this presentation. So a neuron has a dendrites, which are the input channels, and we have a processing unit called nucleus, and we have an axon, which is the output. That's all what we need to know from a computer science perspective for this presentation. We really don't need to know anything else. So in computer science, we simulate the biological neuron mathematically using something called artificial neuron or a digital neuron. So if you see on the right side here, we have the input as variable x1, x2, x3, and xn. Then we have the nucleus, which is mathematical function. One is called linear function, and the other one is called activation function, and we have the output. So this is what's an artificial neuron, what's a digital neuron. So after the slide, when I mention the word neuron, I always mean artificial neuron, but I'm not say artificial neuron. So because this presentation about AI, so definitely it's all about artificial neuron. So this is how we simulate the biological neuron mathematically. So let's talk about learning again. Talk about in human, then we'll talk about how we do that in computer using artificial neuron. So in human, if there is two biological neuron, they want to learn something, they make a connection. And this connection between them is called a synapse. And this synapse strength actually indicate the learning. If it's a weak, they have two type of connection. We have a weak connection and have a strong connection. Strong connection means you're learning something. If you are a weak, you're not learning yet, or you can unlearn something by making this link weaker. So in human brain, there is about 100 billion neurons. A billion is 1,000 million. And we have about 100 trillion synapses, which more than the number of the galaxy, more than number of stars in the galaxy. So how to simulate that mathematically in artificial system, an AI system? So we have a digital or artificial neuron here, as you can see, and we can just put a number in this connection. So if it's zero, means there is a weak connection. If it's one, means stronger. So in ChatGPT, for example, we have about 2 million neuron, and we have 1 trillion synapses. Now, let's talk about artificial neural network or ANN. So in the left side here, we can see this is a simple neural network because it's have 3 layers. By the way, a layer is vertical, it's not horizontal. So in AI, we count layers as vertical. So in this diagram, we have the vertical red circle, then a vertical yellow circle, and a vertical blue circle. So we have 3 layers. The first layer is called input, the second layer is called hidden layer, and the last one is called output layer. Now we call this simple neural network because it has only one hidden layer. The most important layer in neural network is the hidden layer. The more you have, quote unquote, the more intelligent, because it can detect sophistication and pattern in the data. So it's the most important thing is to have multiple hidden layer. And when you have multiple hidden layer, we call it deep learning neural network. So the word deep just mean you have multiple hidden layer. And you can actually rearrange this layer to create different architecture. So that's what we call neural network architecture. So architecture, you are arranging this layer for a different domain for different problems. So as you can see, we can actually achieve multiple goals using different arrangement of these neurons layer to solve different problems. Now, ChatGPT, most of us might know or use ChatGPT. ChatGPT is like a car. And under the hood, if you open the hood of the car, if you look to the engine, in ChatGPT, you'll find an engine called GPT. So GPT is the engine of ChatGPT, which is short for Generative Pre-trained Transformer. So it's a transformer. So what's a transformer? This is the diagram of a transformer. It's a module. It's an AI module that connected to each other to do different tasks. So every rectangle in this diagram, you can assume it's one of these architecture on the left side. So by combining different architecture together and feeding them to each other to do a specific task, we build what you called a transformer or GBT that we used in ChatGPT and other systems. So let's move on now from deep learning. Let's talk about generative AI. So we now know AI is just a phrase that cover anything that's human intelligent. Machine learning is just any system that learn from data. Deep learning is the same as machine learning. The only difference we are using neural networks. So what is generative AI? Generative AI is actually the same as deep learning. The only difference is it creates new content. So that's the keyword, creating new content that does not exist before. So simply they're learning from data and they're creating new content that does not exist before. So let's talk next slide about generative AI. So one of the most common and known generative AI tool is Chat GPT. And as you can see in this diagram, to reach the first 100 million user and the first month, ChatGPT took only 2 months, where other system took years. Like for example, Instagram took 2.5 years, Uber took about 6 years, Google Translate. Now, if you ask why ChatGPT took only 2 months? If you look to this diagram, ChatGPT is the only tool that creates content, new content. The other tools are just transforming information from format to format, or from point to point. ChatGPT is the only tool in this slide that create new content. And that's what simulate the human brain, which have to do with creativity, creating something new. So ChatGPT is not the new AI tool. It's actually one tool in many categories. So if you see the first category in the slide, we have AI bots, we have ChatGPT, we have Google Bard, we have Bing, we have Cloud. So there is multiple tools. Also, there is multiple category. We have video creation, we have images creation, manipulation, we have presentation, how to do slide, research, prompt writing, productivity, and writing. So ChatGPT is just one tool in one category, but as you can see, there is many tools and many categories. So let's compare ChatGPT to the human brain capability. So in the first column here, this is an average human. Their IQ is about 50%. They speak on average 2 languages. They read about 700 before they die, if you assume people die on average 75 to 80 years. And their working memory is about 7 words. Working memory means if I tell you like multiple words, then I ask you to repeat them. That's what we call it working memory. Long-term memory is about 74 terabyte. So you might say, okay, how much is 74 terabyte? So if you approximate it to 8 terabyte, let's just say human capacity brain is about 80 terabyte, and it's equal 50,000 high definition 1 hour episode of your favorite TV show. So let's say your favorite TV show high definition is, I don't know, let's say Game of Thrones. So it's a high definition. And if you watch 1 hour, 50,000 episode, that's equal 80 terabyte, which is the capacity of a human brain, long-term memory. Now, if you compare that to ChatGPT 4, the IQ for ChatGPT 4 is 99.9. It knows more than 90 languages. It's read more than 4 million books. The working memory is about 128,000, and long-term memory is 40 terabyte. You might say, well, it's less than human, but see Gemini at 80 terabyte. By the way, this is ChatGPT 4. We don't know what about ChatGPT 5, which is already available right now. If you're using ChatGPT right now, highly likely you're using ChatGPT 5, and their information and specs are not announced yet, so they actually might be more than Gemini. We don't know. So let's talk about large language model. You might hear a lot and about large language model, or for short, they call them LLM, or LLM for short. So what is a large language model? So a large language model is a deep neural network. It's a deep neural network. So as an input, we put many different type of data, like web data, website, books, images, structured or unstructured data, feed it to this large neural network. And after we train this large neural network, we get a large language model that can be adapted for different tasks, for question answering, for sentiment analysis, for information summarization, for planning or language or whatever. So the product that after training a large language model, we called pre-trained model or foundation model. If you heard about foundation model, that's what they mean. It's just a model that understands the language extremely well, maybe better than human. Now, how large language model actually are built? So simply, when we feed them data, we remove the last word. So for example, here we fed the large language model massive amount of text, and we remove the last word. And the large language model, they try to guess the last word. So the guess first time it's 50%, and it's random. So they might get it, they might not. When it's wrong, they try to go back and try to understand the meaning of each word and connect the meaning with each other. Now, understanding a language and the connection between word It's beyond the scope of this presentation, but we will explain a simpler version of it in the next slide. In a couple of slides, we'll explain how the AI system understand the meaning of the word and they connect the meaning of the word. So this is how they build a large language model. Now, when you build a large language model, you can actually tune it more for a specific domain. For example, if we have a pre-trained foundation model, as we saw in the previous slide, we can do transfer learning to make it specific for a specific industry, let's say for healthcare or something. So if you provide, like, for example, healthcare data or report or diagnostic, you can actually make it more tuned for that specific industry. And this is what we call fine tuning. So the product is called fine tuning and the process is called transfer learning. Now let's talk about how this model understand the meaning of the word. So as I mentioned before, there is multiple ways to understand the meaning, which is called attention. Attention algorithm that's used for the large language model to understand the meaning and the word. In this slide, we're not going to explain attention. We're going to use word embedding, which is very simple to explain. So in this example, if you see the left side here, we have multiple words: cat, kitten, dog, houses, man, woman, king, queen. These are words. And during the training, the AI system, large language model, create attribute or dimension. We call them actually dimension, but we can call them also attribute or features, and try to put mathematical value for this attribute. For example, a cat. Is a cat a human? Put it in a scale between 1 and 0. So it's 0.1, gender 0.4. So try to create these numbers, positive or negative. So this is what you call it dimension. Now in ChatGPT, there is 50,000 dimension. So it's very, very difficult for the human brain to comprehend more than 2 dimension. So for the sake of this presentation, we're going to use dimension reduction. So from 7 domains here to 2 domain. So if you do domain reduction to 2 dimension, we can actually plot them in a paper or a 2 dimension space like here. So as you can see, if you use this number, you can see the cat and the kitten are close to each other because of this value that the large model found between them. Same thing, if you see the distance between the man and the woman, it's almost the same distance between the king and the queen. So this is how they understand the word. They understand it as mathematical value, as mathematical function. So let's talk about large language size. So I forgot to mention here, if we go back to a large language model, these edges between the neurons, we call them parameter, okay? And they are used to measure the size of a large language model. So we call them parameter. So here, in large language model size, if the number of parameter less than 100 billion, we call them a small large language, a small language model. Like OpenAI, it has 117 million. ChatGPT 2 have 1.5 billion, so we call them small language model. When they have above 100 billion, we call them large language model. Like ChatGPT 3 has 175 billion parameter. ChatGPT 4 has 1 trillion parameters. So this is how we measure the size for large language model. Now, how much does it cost to create a large language model from scratch? So as you can see here, ChatGPT 4, it costs 100 million to build ChatGPT 4 from scratch. So it's not possible to do it as an individual. It's just massive, big, huge investment. So this is why training large language model is only done by big companies because they have the money and resources. So it's not only it costs money, it's actually cost a lot of electricity. So if we assume ChatGPT 4, just for simplicity, it costs 10 um, billion petaflop. So electricity in large language model in computer, we use a phrase called a flop. So what's a flop? A flop is floating point operation. If you remember the calculator on the first slide, we use two flop. We use the plus and the equal. So there is two mathematical operation, float point operation. So in large language model, we use petaflop. A peta is 1,000 trillion, and a trillion is 1 million million. So here, a 10 billion petaflop costs about 2.5 thousand home electricity of 1 year. We consume it in 1 month to do the training. So it's a massive amount of electricity. That's why they need, as I mentioned in the beginning slide, they're planning to build their neural network, nuclear reactor because there is no enough electricity. Actually, one of the main limiting factor of AI advancement is energy. There is no enough energy. And this is why this big company is looking for alternative for energy rather than using the public grid electricity to operate and train their large language model. This is one of the common misconceptions that ChatGPT consumes 10 times of electricity compared to Google. It's not actually accurate. It depends in whether you're asking a simple question or a deep question. So if I'm asking a simple question, what is this or what is that? It's actually similar to Google consumption, but when you ask analyze or compare and contrast, it's it's actually Google using the same thing right now. So it's not that big difference. Also, if you're using TikTok or gaming or driving electricity or using flight, you're actually using also a lot of electricity compared to large language models. So this difference was 5 years ago, might be accurate, but now because of advancement of algorithm and efficiency, this difference might not be accurate right now. So in fusion energy, so one of the clean source of energy that's a big company trying to invest is the fusion energy. So as you can see here, in one uranium pellet, it can give you the same power or energy from 17,000 cubic of natural gas or 120 gallon of oil or 1 ton of coal. But the problem with the nuclear fission or nuclear energy is the nuclear waste and the danger to the environment. So that's why if you follow up about nuclear energy, they're actually shifting from nuclear fission to nuclear fusion. Nuclear fusion is actually considered green and considered no radiation. There is, but it's very short-lived. It's about 10 to 5 or 10 years. So that's why they call it clean and they consider it no radioactive material because it's very short-lived. And actually to produce 4 times more energy than the nuclear reactor, the fission one. So that's why there is a trend to go to fusion energy. Unfortunately, we don't have in the US too much investment. For example, China invest 1.5 billion compared to the US 800 million in the last couple of years. In 2000, actually 23, China investment more than all the world combined in fusion energy. And it's considered actually the king of fusion energy. And that's actually a national security problem because it looks like here in the US, we are busy building the car. You assume the car is the AI system, but we're not thinking about fueling the car, which is what China is focusing is how to fuel the car. So it looks like if we continue doing that, actually China might have the upper hand in AI above the US. Now to encourage fusion energy, um, there is multiple national lab. For example, this national lab, D3D in UC San Diego, they have open actually days and for visitor in person online, and they have actually in May every year they have a fusion energy week that it might help to separate the word between research and student to conduct research. Now you might say, well, I'm not a physicist. How do I research? with the fusion energy. Actually, you don't need to be a physicist. Actually, when I visited the nuclear reactor uh, in San Diego, they're actually looking for data scientists. They're looking for computer scientists more than physicists because they want to simulate the data and simulate the plasma because turning on and off the nuclear reactor is very expensive and they have massive data and they really want to work on the data. So as you can see here, this is an example of a computer scientist from San Francisco State University. He actually won an award from the US Department of Energy of using actually computer science machine learning to simulate and predict the results of a fusion energy reaction. As you can see, there is a lot of award for doing research using AI and fusion energy, uh, which you can find in the Department of Energy website. So I encourage everyone to spread the word of the importance of doing fusion energy research using AI if you really want to push the AI research. Because as we talked before, energy is extremely important and actually the main limiting factor of AI research, it's the energy. Now let's talk about enhancing large language models. So we talked before how to build large language model. Let's talk about how to enhancement when it's come to accuracy. So I will talk about the most, in this slide, we'll talk about the most uh, difficult way to enhance the accuracy of large language model to the simplest way. So the first way to enhance a large language model accuracy is to train them from scratch. But as we saw from the previous slide, it's cost about 100 to 200 million US dollar to train a large language model from scratch. So apparently this approach is not practical for average people, for this is only for big, massive companies. The other one is to do fine tuning. So fine tuning, you take a large language model, a foundation model, pre-trained model, and you train it in a specific domain to increase its accuracy. So that's called fine tuning. Again, fine tuning is not cheap, is not easy. Definitely less expensive than pretend, but it's less. But it's still, it might cost 1 million to 5 million to do fine tuning based on the size of the large language model and the data you have. But it's still expensive. Now, retrieval augmented generation, RAG, it's the most common technique to improve large language model and actually the most used technique by researcher and actually the one that I used when I teach in my class. I actually use it as a project for my students. So this is open source. This is easily can be done in 3 months as a research project. We'll talk more detail about RAG, which is retrieval augmented generation, and next slide for more details. But it's a tool, a technique to enhance the accuracy of large language model for free using open source, and you can do it using uh, open source system and data. The last technique is prompt engineering, which actually almost used by all of us. When we use an AI, we use prompt engineering. So what's prompt engineering? Mainly when you ask a question, you just put more data, you put more context, and that's what's prompt engineering. And this is how to improve the accuracy of AI tool when you use them. Like when you use ChatGPT, if you put more details, you increase the accuracy of the result. So let's talk about retrieval augmented generation, since it's the most important for research, how to improve the accuracy of large language model without training them from scratch or without doing fine tuning. So in general, let's explain the old way of using large language model. Let's talk about, for example, ChatGPT. When you use ChatGPT, you usually ask a question, and the large language model, the engine under the hood in ChatGPT, will answer your question as a response. So this is the traditional, regular way of using large language model. Now, RAG is different. When you ask a question, there is a system will interrupt your question and take it outside and find a relative document in your company or in your research or in your domain, then bring back your question with a set of documents that's relevant to your question, then submit them to the large language model. So the large language model will use only the document from the retriever to answer your question. So this is how we improve the accuracy. So notice here, the RAG will interrupt your question and take it aside, and then use it to find the relevant document from your domain or your corporation or your website or whatever data you have. Then submit the question with the data, with this file to the large language model, and large language model will use only this file to answer a question. So this is how retrieval augmented generation. Retrieval-augmented generation is very common, and you'll hear the word RAG a lot in AI research. So that's what does it mean, RAG means. It's using an open source system to improve the accuracy for a specific research. So here is a summarization without RAG, what will happen if you use a large language model without RAG in your research. Ungrounded hallucination. We just call it hallucination, means inaccurate data. We don't need to go in details. There is multiple type hallucination. There is grounded and ungrounded. But for us, we'll just say hallucination. Old information, new data, no idea what does that mean, and it's not my data. Let's use generic and the internet available data to train the system. With RAG, you can have grounded and source data. You can actually not only answer question, you can actually answer question with citation, because you know exactly which document have the answer for that question. And the data is always up to date, as comprehensive as a search. And you can use data to train that large language model. So simply, RAG is retriever. You search from your data, argument, you add it to the prompt, and you use it with the generative AI. Now, let's talk about HPC, high performance computing, and let's see in the next slide why it's related to AI and why it's important to AI. So high performance computer, it's kind of a supercomputer, which consists of multiple machines connected with each other, call them compute node. And as a user, you log in to the login node, and you have the power of all these computer behind them. So there is multiple NSF, Foundation, National Science Foundation initiative that give you access for free to these supercomputer to use them to do any type of research you have, whether it's AI or non-AI. For example, we have ACCESS, which is an acronym for Advanced Cyber Infrastructure Coordination Ecosystem Service and Support. And we have the NAIR pilot, which is National Artificial Intelligence Research Resource. So these are NSF initiative to give free access to supercomputer to conduct research. So they have supercomputer access, they're free usage, they can be used for STEM and non-STEM for access. NAIR project, it's only used for AI research, but access can be used for anything. They have free training and support, and access also can give you, they have some grant for projects. If you want to learn more details, you can visit their website, access-ci.org or nairpilot.org. Now, you might say, okay, why is that related to AI? Why HPC is related to AI? Well, AI is the algorithm, is the technique. HPC is the power that operate this algorithm. So combining both AI or HPC, that's where you're doing the real innovation and creativity and push science. You need to use both. You can't just use AI by itself, because AI need CPU cycle, needs in its computer power, and this computer power comes from HPC. That's why we combine them together. Almost everywhere, whenever you talk about AI, you need to talk about HPC. So combining together the power of AI and the power of computation, HPC, you can do real research and real science to push the boundary of science, whether it's for fusion energy or medicine or physics or climate or any research. So let's talk about AI ethics. So in AI ethics, there is multiple domain that need research more and more in these areas. For example, transparency. How these neural network or large language model actually make decision internally, how they work inside. Actually, until now, it's not clear 100% how actually work inside. And that's why if you read research about AI, you might hear the phrase emerging feature or emerging technique or emerging. Emerging means this neural network learn and they find, reach this conclusion, but we don't really understand how they learn. So that's transparency. And it's normal. We're at the beginning of this AI evolution, AI cycle, but we need more research in that area as transparency, how they work internally now, how they reach these conclusions, how they reach these results and big neural networks. Accountability. We need to understand actually who is responsible about this result. If you're driving an electric car, self-driving car, and there is an accident, who is responsible? Is it the driver? Is it the neural network inside the car? Is it the company? Is the CEO? So we don't have enough laws and understanding about the accountability for AI system. Same thing for privacy and security. Security. The data that's used for training, where this data came from. Are they copyright material? Are they open source? If they are not open source, are they secure? Are they saved and encrypted in a specific way? We might also need to know more details there. Bias mitigation. This is a huge problem right now, bias mitigation. If you use data that's cover a specific type of people, the result might not be generalized to all people. You can do a simple example. If you go and ask ChatGPT or another AI tool, draw a picture of a truck driver. Usually you will see a male truck driver, not a female truck driver. Now, why and how to solve this issue, we need more research because right now AI is just reflects the training data. Whatever you put in the training data is AI is just a mirror, it's a reflection. If there is a bias in the data, definitely you will see it in AI result because AI right now is just a mirror, it's just imitating whatever exists in the data. Empowering human. We need to empower human using AI tools. And you might hear this a lot in the news, and actually it will happen more and more in coming years about AI replacing some job or the task force or people are concerned or afraid about AI taking over. How to empower people? To empower people, use AI. The more you use AI, more you will be more used to it and more professional using this AI to improve optimization and resources. And this is how we can empower a human by using AI tools in any job they are doing. So the best thing is to empower human is just to use AI tool. Whatever you're doing, whatever your job, use AI tool to optimize the work and result and the resources. Human control. We don't want to have AI 100% independent to make their own decision. We want to have human control, especially in mission critical systems. We want to have human control, at least to have the last word, the last decision when it's come to mission critical system. So again, these are open for research. We really need a lot of research in this area. It's open, it's a new, so there is a need for research in these areas to cover the AI ethics. Now, let's summarize the presentation. So this is a summary of almost the whole presentation. So first we talk about AI, which simulating anything that simulates human brain. Then we talk about machine learning, which is a class or a category of artificial intelligence, which simply learn from data. Then we talk about deep learning. Deep learning is a class of machine learning. It's actually using neural network to learn from data. Then we talk about generative AI, which is a type of deep learning, which creates new content from learned patterns, and we talk about large language model, which is a type of generative AI that understand language very well, which is a human language or a programming language or any language. So what are the essential skill to learn to participate in AI research? So you might heard about AI in education, AI literacy, AI in education or AI education. So whatever, if you are an educator, if you want to use AI for tools, or you want to improve AI literacy for in your for your students in your class or university, or you want to deep dive inside the technical details and build a neural network and build the AI system. Uh, I suggested this list, very short list, just 4 items, how you can actually learn and whether you learn and participate in research. So the first tool that I would recommend is ChatGPT. And most people know about ChatGPT. And what is ChatGPT? It's not about knowing ChatGPT and using it. It's about how to use it correctly. So I use it to solve problem, use it to reason, use it to write code, and actually to have different alternative way to solve the same problem. So you can ask ChatGPT how to solve this problem in multiple ways. Give me the pros and cons in each way. So this is the more you use ChatGPT, the more you get better about using it. Also, there is Google Notebook LM. So simply, what is Google Notebook LM? It's a RAG system. We already explained what is RAG, so I think that will be enough to just tell you Notebook LM is a RAG system. So let's say you want to do a literature review. You are a researcher. So, and if you did a survey paper before, it's extremely time consuming. You need to read, minimum 100 to 500 research paper. That take about 3 to 6 months. It's massive with even a research team. In Notebook LM, it might be take actually a couple of hours. Why? Because it's a RAG system. You upload all your research paper, 100 or 500. Then you ask question, compare and contrast between all these research paper. Find this, find that. Draw a diagram, calculate, compute. It's a RAG system. It's make research extremely easy and fast. Um, the next one, we have Google Colab. Google Colab is a short from collaboration. And a Google Colab is a visual um, programming in Python. It's make it visual. It's not only text. So you can have code, you can have animation, you can have your data, and you can have it actually line by line. So it make programming and visualization easy. So it's considered a building block and learning AI system and building AI system. The last one I advise to learn is PyTorch. So PyTorch is open source, deep neural network that is optimized for GPU use and research. So this is more for technical. If you want to do AI education, if you really want to go in deep technical, this is what the library to start with is PyTorch. Now I built 14 workshop about AI for actually beginner, for high school kid, for high school student. And of course, it can be used by anyone. So I have them, these 14 workshop are available in my GitHub for anyone who might be interested, and they're open source. And they start from zero, from nothing, and they build up step by step until they teach you how to use build actually using neural network, how to build a large language model, how to build a RAG, I mean, how to use a RAG to customize a large language model, how to use deep neural network. So everything we covered, if you want to do it programmatically and technically, you can use these workshops, which are actually use simple, very simple language and originally designed for high school student, but of course it can be used by anyone. So the 14 workshop is divided to two group using PC, using your personal computer. Then you can do them again using HPC, high performance computer, using supercomputer. So I'll show you how to do them. The workshop explain how to use Access initiative initiative to access to have supercomputer. My research, I have a research lab here also in my university, California State University, and I'm open to collaborate with anyone who's interested to conduct actually AI research or anything related to quantum or fusion energy or semiconductor using AI. So I'm not only interested in AI research, I'm actually interested in AI application in quantum and fusion energy or semiconductor. So if anyone interested, they're welcome to reach out to me. And this is a summary of my research that I'm working on right now. And that's the end of my presentation. Thank you.
Nabeel, thank you again so much for coming and giving this presentation for us today. Um, I'd also like to thank everyone who came to attend. Thank you to all of our attendees. We do one or two of these webinars every single month. So, keep an eye out on your email, keep an eye out on the WEC Access and the NAIR website for all of our upcoming webinars. We're really excited to share these with everyone moving forward. And again, if you'd like to rewatch this presentation, it will be up on the Nair Pilot YouTube channel within the next 2 weeks. Thank you, everyone, and I hope you have a fantastic rest of your Monday.